We will continue chemistry in everyday life. Broad spectrum antibiotics. Broad spectrum antibiotics we have seen. Next we will see narrow spectrum antibiotics. Narrow spectrum antibiotics. Narrow spectrum antibiotics we will see. It is effective mainly. It is effective mainly. It is effective mainly against gram positive or gram negative bacteria. Against gram positive or gram negative bacteria. For this, what is the example? For this example is penicillin G. For this example is what means penicillin G we can say. Next we will see limited spectrum antibiotics. Next we will see limited spectrum antibiotics. Limited spectrum antibiotics. It is effective against a single organism. It is effective against a single organism. It is effective against a single organism or disease. It is effective against a single organism or disease. It is called a limited spectrum antibiotics. Sir, this regarding penicillin. This penicillin is manufactured at where in India, in the sense Hindustan Antibiotics in Pimpri. Next, we'll see about chloramphenicol. This chloramphenicol we'll see. This chloramphenicol is observed in gastrointestinal tract. Gastrointestinal tract and is used for the treatment of typhoid and is used for the treatment of typhoid, used for the treatment of typhoid, dysentery, acute fever, urinary infection, meningitis, and pneumonia. Next antibiotic we'll see. Next antibiotic, dicidoxyrin. This antibiotics is toxic to certain strains. Of cancer cells. Next we will see antiseptic. Next we will go for antiseptic. What is antiseptic? We will see. This chemical will kill or prevent growth of microorganism. It is a chemical which kill or prevent The growth of microorganism. The growth of a microorganism. This chemical is killing or preventing the growth of microorganism, we can say. Next point we'll see antiseptics. Antiseptics is applied to living tissues. Antiseptics is applied to living tissues such as wounds, cuts, ulcers, and diseased skin surfaces, diseased skin surfaces. For this, what is the example? For this antiseptic example, we will see furosine, soframycin, Dettol. In the Dettol, we'll see two things. One is chloroxylenol. Chloroxylenol formula we'll see benzene ring, one OH group, para to this Cl, ortho to this CH3 on both sides. Chloroxylenol. In Dettol, another one we'll see. Terpineol. Terpineol we are taking. This terpineol is a cyclohexane ring. Here pi bond. Here one CH3 group we will write. Here one OH group, one CH3 group, one CH3 group. Dettol. These two are Dettol. For antiseptics, another example we will see. For antiseptics, another example we are seeing. This compound name is bithionel. Another name is cithionel. Here benzene ring we will write. It is bonding through sulfur with another benzene ring. Two benzene rings bonding with sulfur, through sulfur. Sorry. Next, substituents will see here one OH group, ortho to this Cl, meta to this Cl. In the same manner, this side. Here OH, here Cl, here Cl. It is bithionel or cithionel. This is what in the sense here one correction is there. Here bithionel. This bithionel. Oh, bithionel only one name. This bithionel, regarding bithionel, we'll see. This bithionel is added to soaps. To impart antiseptic properties. Antiseptic properties. So bithionel is added to a soap for what in the sense? For antiseptic properties. So next antiseptic we will see tincture of iodine. Tincture of iodine. This tincture of iodine contains what means iodine 2 to 3%. Then in this alcohol is there, and in this water is present. This is for what sake we are using this tincture of iodine in the sense to wash wounds. This tincture of iodine is used for washing wounds. Next antiseptic is what in the sense iodoform. Next antiseptic is what means iodoform. Next antiseptic we will see boric acid in dilute aqueous solution. Boric acid in dilute aqueous solution. Boric acid in dilute aqueous solution is weak antiseptic. It is this weak antiseptic is used for what in the sense for eyes. This weak antiseptic is used for eyes. Next we will see disinfectant. Next we are seeing disinfectant. Antiseptic is over. Now we are going for disinfectant. This is also for what means to kill or prevent the growth of microorganisms. Okay. Disinfectant is a chemical. Disinfectant is the chemical. For what sake it is used in the sense it is used for killing or preventing growth of microorganism. Growth of microorganism. Okay, and this is a disinfectant. This disinfectant is applied for which cases? This disinfectant we can apply for which case? This disinfectant is applied to inanimate objects. To inanimate objects. To inanimate objects like floors, drainage system, instruments, etc. So this disinfectant we will apply for these in order to kill the microorganism. Sorry. Example for disinfectant we will see. One example is 0.2% solution of phenol. 0.2% solution of phenol is an antiseptic. While it's 1% solution is a 1% solution is a disinfectant. 1% solution is a disinfectant. So disinfectant in the sense 1% solution of phenol, antiseptic in the sense 0.2% solution of phenol. So 0.2% solution of phenol means antiseptic, but concentration increased to 1% in the sense that is acting as a disinfectant. So another example of disinfectant we'll see. Another example of disinfectant 0.2 to 0.4 ppm. 0.2 to 0.4 ppm parts per million of Cl2 aqueous solution. Cl2 aqueous solution is an example for a disinfectant. 0.2 to 0.4 ppm of Cl2 aqueous solution of Cl2 chlorine. Aqueous solution of chlorine is an example for disinfectant. Next example is a very low concentration of sulfur dioxide. Very low concentration of sulfur dioxide is act as an example for a disinfectant. Next we will see antifertility drug. Next we are seeing antifertility drug. For this antifertility drug, we will see the example. Drug name we will see ethinyl estradiol. This is a Novostrol. Commercial name Novostrol. This Novostrol is what in the sense? In this one, estrogen derivative will be there, progesterone derivative will be there. In this, what is there means estrogen derivative is estrogen derivative is there, and another derivative is there, progesterone derivative. Progesterone derivative. Progesterone derivative is there. Okay. So this ethinyl estradiol or novestrol contains estrogen derivative and progesterone derivative. It is a antifertility drug. What is the role of this progesterone? That we'll see. This progesterone suppresses ovulation. Next point we'll see in this one, northindrone will take. This is used for what in the sense? Northindrone is a synthetic progesterone derivative. Northindrone is what means synthetic progesterone derivative. Progesterone is a suppresses ovulation. Okay, so we have seen about anti-fertility drug. The anti-fertility drug is this is one drug and this is one drug. Okay, then we will go for food additives. Next we are going for food additives. We will see food additives. In this one, first one we will see food colors. We will see food colors. Food additives. In that first one is food colors. Some colors will be added. Next, food additives is flavors and sweetness. Next, food additives is fat emulsifiers. And stabilizing agents. Next food additive is flour improvers. For this example, this is what means anti-staling agents. Flour improvers are anti-staling agents. And bleaches. Next food additive is antioxidant. Next food additive is preservatives. In order to avoid destroy. Next food additive is nutritional supplements. Like minerals, vitamins, and amino acids. These are what in the sense food additives. These are called food additives, we can say. Next we will see artificial sweetening agents. Artificial sweetening agents. Aspartame. For this, what is the formula in the sense? Carboxylic acid, CH2 group, CHNH2, CONH amide linkage, then CH2 phenyl ring, then ester group CH3. This is actually what in the sense it is like peptide. In this peptide, what are the parts are there means this part, if you see, this part is a aspartic acid part. Aspartic acid part, that means amino acid. Aspartic acid is one amino acid, that part. Then this is what in the sense phenylalanine. Phenylalanine means from year to year, this it has to be carboxylic acid, but it is ester, therefore it is methyl ester part. Phenylalanine methyl ester part, we can say. This is aspartame. So aspartame contains roughly 2 amino acid derivatives in the peptide form, and also this here carboxylic acid should be there, but instead of that methyl ester part is there. So what is the role of aspartame? This aspartame, it is roughly 100 times as sweet as cane sugar. Next, it is used in cold foods. It is used in cold foods. And soft drinks. Cold foods and soft drinks. Because it is unstable. It is unstable at cooking temperature. Therefore, this aspartame we have to use for cold food only. We have to use. So, at higher temperature, what happens means it undergoes a decomposition. So, next we will see saccharin. Next we are seeing saccharin. Saccharin structure we will see. In the saccharin structure, benzene ring is present. Then amide linkage. Amide linkage means CO and NH. Then SO2 group present. This is saccharin. What is saccharin? We'll see. It is nearly 550 times. As sweet as cane sugar. So, next, it is inert and harmless when taken. It is inert and harmless when taken. Next we will see sucralose. This structure we will see. We will take a chair form. We are taking chair form. Here ether linkage. Chair form we have taken. Here we will take a furanose form. Here we are taking furanose form. So next groups we will give. In the furanose form, at this carbon CH2Cl at up, hydrogen down. Here up H and down OH. In this carbon OH up and down H. Then in this carbon CH2Cl is there. It is making ether. This carbon is making ether linkage with this carbon. Then at this carbon, what is there means hydrogen is present. Then this carbon is having axial H, equatorial OH. Here equatorial OH, axial H. Here axial Cl, equatorial H. Here axial H, equatorial CH2H. This is what in the sense sucralose. This is this sucralose is what? This sucralose is what? It is a trichloro derivative of sucrose. Trichloro derivative of sucrose. That means sucrose contains what in the sense alpha D glucose and beta D fructose. So this is beta D fructose in this. This is OH group. This is OH group. If you give, it is beta D fructose. If you give this is OH group, it is alpha D glucose. So instead of this OH group Cl, instead of this OH group Cl, instead of this OH group Cl, if you are giving in the sense it is trichloro derivative of sucrose. So this sucralose is a trichloro derivative of sucrose, we can say. So what about its sweetness? That we will see. It is nearly 600 times. It is nearly 600 times as sweet as cane sugar. As sweet as cane sugar. As sweet as cane sugar, we can say. So it is stable at cooking temperature. It is stable at cooking temperature. It is stable at cooking temperature. It does not provide calories. It does not provide calories. It does not provide calories, we can say. So next we will see allitate. Next we will see allitate. What is the chemical formula of this allitate? That we will see here. Carboxylic acid, CH2, CHNH2, peptide linkage CONH, peptide linkage CONH, then CH3, then peptide linkage CONH, then next group is CH, C, here S, here two methyl groups, here C, here two methyl groups, okay. This is allitate. What about this allitate sweetness? That we will see. It is nearly 2000 times. It is nearly 2000 times as sweet as cane sugar. As sweet as cane sugar. As sweet as cane sugar. Next, its control of sweetness. Its control of sweetness of food. Control of sweetness of food is difficult. While using it. Next we will see food preservatives. Next we are saying about food preservatives. Food preservatives we will see. In the food preservatives, first point we will see it prevents spoilage of food. It prevents spoilage of food. It prevents spoilage of food due to microbial growth. Due to microbial growth. Due to microbial growth. Sorry. What is the example for this food preservative? Table salt, sugar, vegetable oils, sodium benzoate, of sorbic acid, sodium benzoate of sorbic acid, sodium benzoate of sorbic acid, and salt of propanoic acid, and salt of propanoic acid, salt of propanoic acid. Okay. Next point in this one we'll see sodium benzoate. Sodium benzoate is used in limited quantities. Is used in limited quantities. Is used in limited quantities and is metabolized in the body. And is metabolized and is metabolized in the body. And is metabolized in the body. Next we will see about soaponification. Next we will see about soaponification. Soaponification in the sense hydrolysis of ester and getting soap. That's all. Ester on hydrolysis gives soap. In what medium? In the sense in basic medium. Okay. So we will take a ester. Which ester? In the sense triester we are taking. Triester C17H35. It is ester. Triester we are taking. So here this ester group we will say here O, here C double bond O, ester. Here also ester C17H35. Here we can say CH2O, CO, C17H35. This is ester. It is undergoing what in the sense basic hydrolysis. Undergoing basic hydrolysis to give what? So first we will see hydrolysis with water. We'll see it is undergoing hydrolysis. So this bond is breaking. So here H, here OH. Similarly, this bond is breaking. Here H, OH. Here this bond is breaking. HOH. So we are getting glycerol. Glycerol is one compound. We are getting what compound in the sense glycerol. Another name is glycerin. Another name is glycerin. So what we are getting in the sense C17H35 COO-Na. C17H35 COOH we will get. COOH. How many times means 3 times we will take. So 3 times water. Water is attacking. Now here medium is what means basic medium, that is sodium hydroxide. This carboxylic acid reacting with the sodium hydroxide to give sodium carboxylate salt. This is what in the sense it is soap. What is the name of this soap in the sense sodium stearate? This soap name is sodium stearate. Therefore, this is what in the sense it is giving glycerol and sodium stearate. So that this is called what in the sense stearic acid. So this stearic acid is obtained by this alcohol glycerol and carboxylic acid, this stearic acid. So that it is called glyceryl ester of stearic acid. Glyceryl ester of stearic acid we can say. This is fat. This glyceryl ester of stearic acid is fat. This sodium salt of carboxylic acid is soap. So fat on hydrolysis in basic medium gives what in the sense soap. This fat on hydrolysis in basic medium gives soap. Okay, this is called saponification. In this saponification, in this hydrolysis, what is a medium means a basic medium we have considered. Next example we'll see for soap. For soap, next example is sodium palmitate. Sodium palmitate. For this chemical formula C15H31COO-Na. Next one is sodium oleate. Sodium oleate. For this chemical formula C17H33COO-Na. Sodium oleate. So sodium oleate means C17H33COO Na. Sodium palmitate means C15H31COO Na. Sodium palmitate. Sir, okay. This is about soap we said. Next we will see types of soap. In types of soap, first we will take toilet soap. Toilet soap we will take. This is in this toilet soap, better grade oil, better grade oil or fat is used. Better grade oil or fat is used. Then care is taken to remove excess alkali, to remove excess alkali, to remove excess alkali. Then color and perfumes, color and perfumes are added, color and perfumes are added in this toilet soap. Next we'll see floating soap. Next we'll see floating soap. Next we'll see floating soap. This floating soap, it is made by beating tiny air bubbles, beating tiny air bubbles before their hardening, before their hardening. It is called a floating soap. Next we will see transparent soap. Next we are seeing transparent soap. This transparent soap, how to make, that we'll see. It is made by dissolving the soap in ethanol, dissolving the soap in ethanol, and then evaporating the excess solvent, and then evaporating the excess solvent, and then evaporating the excess solvent, and then evaporating the excess solvent. Next we will see medicated soap. Next we are seeing about a medicated soap. Next we are seeing about a medicated soap. In the medicated soap, what is there means a deodorant will be there. In the medicated soap, deodorant will be there, and the medicinal substances are added. And the medicinal substances are added in this. Medicinal substances are added. Next we will see shaving soap. Shaving soap we will see. This contains what? It contains glycerol. It contains glycerol to prevent a rapid drying. To prevent a rapid drying. Then it contains sodium rosinate. It contains sodium rosinate, which lathers well, Next we will take laundry soap. Laundry soap we will take. This laundry soap contains what we will see. It contains sodium rosinate, sodium